Richard, this is a very interesting solution we've got here from Ward High Tech. Tell us a little bit about it.
This particular project is to assist the customer to load the parts with the operator with a minimum of intervention.
And when we talk about loading parts here, this is an extrusion, isn't it? You've done all the fixturing, you've done all the turnkey package, correct?
Exactly. With the hydraulic clamping that you'll see, it takes out any discrepancy that may come from the operator, and the actual clamping of the part will trigger through an air sensing switch the actual cycle start. So there's no delays. The operator can't delay by talking to his colleague before pressing cycle start.
And the whole idea behind this is productivity, isn't it?
Yes, exactly. And also quality of part and consistent clamping, therefore part to part consistency.
Let's talk about the part, because this, as I said already, it's an extrusion. What are you doing on it? Are you just milling, are you drilling, or are you interpolating?
It's actually a very interesting process because on these extrusions we don't drill, we interpolate the holes. And the reason why we do that is to give the minimum burr so that when the part's finished, it's no good having a cycle time of 2 minutes and taking 10 minutes to deburr.
Is there a tolerance though with that? Are you looking to interpolate to a certain...
We can get circularity on our machine. We can have within 5 microns.
Right, now with this being an extrusion as well and the way you're clamping it with the hydraulics, is there any threat to crushing the extrusion?
No, not really, but what you'll see if we on the actual program run is we machine the part in a very deliberate way because of the flimsiness inherent in the extrusion. So we don't do it where you would maybe mill conventional steel parts, but we come out at nibble away, but at very, very high speed.
Because the thing that strikes me as well is about chatter. Would you not experience chatter on some of the...
This is another benefit of the hydraulic clamping. With hydraulic clamping, the customer's experienced, he can probably use double the feed rates without moving the part, without any chatter. And that's compared with manual nuts and bolt type clamps.
The actual machine that we're talking about here, Richard, the MCV 1200 from Darley, why was this machine selected and what's good about it?
It's got very fast rapids, 36 metres a minute in the X and Y. It's compact in the Z, so we've not got a lot of excess movement. And we can machine the part, which is 1170 millimetres long, on a machine that's only 1200 millimetres stroke. So we're maximising the true potential of the machine.
Yeah, it looks like you've got the fourth axis unit overhanging the table.
That's to give this facility to make the absolute maximum of the machine. If we went to the next size machine up, then our rapid rates would halve. So it's a very productive solution, and it's a proven solution because we've got 8 other machines using the exact same concept that's run for 5 to 6 years.
And with this machine, machining this extrusion, how fast are you machining it with the spit? What's the capabilities of this?
Very fast. With a 15,000 RPM spindle, we're going up to 8 metres a minute feed rates. With the hydraulic fixture, we've been able to double the feed rates that were achieved previously on manual clamping. If we ran these feed rates on manual clamping, we'd pull the part out of the fixture.
Right, okay. And the loading of this then is still done by a human, correct?
Yes, yes. And it's very, very quick.
So what have we got here as well? Because the doors, you've got an auto door.
Yeah, auto door facility with light beams. The light beam is there if the operator forgets a spanner or puts something or tries to go in because the machine will stop. But the whole advantage of this system is that the clamping of the part, they have an air sensing switch that says I'm clamped, and that then triggers cycle start. So all that is automatic from the point of view of starting the machine for every production part.
So the only thing the operator needs to do is literally take a part out and put a new one in?
Yes. Everything else is out of his hands.
The turnkey solution, Ward High Tech, is this something you're good at?
Yes. We've done this principle, as I mentioned before, but this is taking it to the next stage.
And not just on, let's say, this Darley Machining Centre, but yourself, you do a lot of turnkey projects on maybe the SFM machines or the Watch-on machines?
Done quite a lot of projects using auto doors, even coupled up with robots. Just whatever solution the customer requires,
You've got an engineering team to support that.
Yes. Yeah.
And I think with the way in the future, automation is a big part, isn't it? So it's good to be able to offer this type of solution.
Right. Especially with the new style of robots, which require now very, very minimal guarding because they've got their own sensing equipment and they can trigger any interference from the human person within a certain radius.
And a quick word on the Parks and fourth axis unit here. That is sufficient in its speed to rotate the the part.
Yeah, the Parkson table that we've got is a very accurate table, and also we've especially for this project, we've equipped it with hydraulic clamping, and that effectively doubles the clamping force for any machining. So it really complements the high-speed machining, heavy feed rates that the customer wants, and gives a very stable unit. But it's also coupled with a hydraulic clamped tailstock, so the parts clamp from both ends.
How long did it take Ward High Tech to put this solution together from order to ready to go in?
From once we got the concept, once we got the fixtures ordered, we've probably spent 2 weeks developing and setting up the process. We've had 2 visits from the customer to satisfy them, that culminated in successful machining trials.